So today we're going to go over how do we graph sine functions. So sine functions make this general shape. Now we can adjust this shape and we'll see different examples of that today, but they make this general shape. So whenever you see sine, I want you to think of these two land formations. We're going to make a hill and then we're going to make a valley. How many of you have ever had to learn a dance before and you learned it based on steps, like an 8 count or a 4 count? Anybody here has ever had to learn an 8 count, 4 count, that kind of thing? Okay, so we are going to always do a 4 count. This is like a dance, and we are always going to do a 4 count every single time for a sine function. Now, how does this start? We always start here at the origin, and then we'll learn when we can adjust that when we translate it left, right, up, and down later on. But to start with, we always are starting at the origin. And then when we make the 4 count, the very first move you make, so step 1 is going to go to the highest point of the hill. So please do that. Make a point. Step 2 goes back to what we call the midline. It's back on the x-axis. So I've just taken care of the hill. Hill was, we had a starting point. Hill was step 1 and step 2. Now valley is going to be step 3 down to the lowest point, and back up to the midline is going to be step 4. And we just did one cycle of a sine curve. So sine curves make this wave shape. What you don't want to do is make a sharp V. So we're going to make right here a rounded part and a rounded part down here. That is one cycle. It's one cycle of a sine curve. Now, it doesn't end here unless we have some type of interval that says only do one cycle. It continues to go on to the left and it continues to go on to the right. And obviously I didn't make it pretty, but it makes this wave, this constant wave shape, okay? Just remember again that sines go hill and then valley, and it is a 4 count. All right, we're going to start off with the most basic one. This is one cycle. Now, this cycle can take on different shapes. Please watch this really quickly. So this would be like what we just talked about. It goes hill and then it goes valley. Or it's possible, think if I had the ends here and I took it and I pushed it closer together. It may look like this. It may go like hill, valley. Does everybody see that same shape? It still does a 4 count. It starts here and it goes 1, 2, 3, 4. But it's been compressed. Or it's possible that we do this shape and we take the ends and we elongate it or expand it. And it looks like this. 1, 2, 3, 4. Everybody see that? So how do we determine how long one cycle is going to be? That's called the period length. So if everybody could write down period length. Sometimes on paper, to save space, they just write down the word period. And period represents what is the length of one cycle. This is the first thing we should always start with. If you're a procedural person like I am, like, just tell me, right? Just tell me, what do I do first? The first thing you do is you find what is the period. So I'm going to start with y equals the sine of x. This is the most basic sine function. So how do we find the period length? To find the period length of this, we will always write 2 pi for sine functions. And on the bottom here, we're going to put a value. The value we write on the bottom comes from whatever is in front of the x. You may be thinking, I'm looking up at this equation and I see no number in front of the x. What number is hiding there if you don't see a number? A 1. So 2 pi divided by 1 is just simply 2 pi. What does that represent? That means that when I graph this, one cycle, if I measured it, is going to be a length of 2 pi. Okay, tell me again, how many steps does every sine function have in one cycle? How many steps? 4. So the next thing we're going to do is we're going to measure every single time from one step to the next. It's the exact same length on the x-axis. We're going to measure what is that distance. And so we take whatever is, this is step number 2. If you're a person that's procedural, step 2, it's called the x scale, and it measures the horizontal distance between the steps. It measures the horizontal distance between the steps. And so what we're going to do for step 2 to figure out what's called this x scale is we are going to take whatever our period length was, in this case it is 2 pi, and I will always divide by 4. Why am I dividing by 4? Because I want to take that and I want to divide it into equal spaces. So 2 pi divided by 4, well, 2 over 4, 2 goes into itself once and 2 goes into 4 twice. That equals 1 pi over 2. What does that mean? That means if I came back up here, from here to here is a distance of 1 pi over 2, a distance of 1 pi over 2, a distance of 1 pi over 2, and a distance of 1 pi over 2 again. We're going to start by graphing this one together. So if you could zoom in, please, and find this one right here, number 1. We have already determined that the period is 2 pi over 1, which reduces to 2 pi. And we have determined that the x scale is 1 pi over 2 when we reduce it. Okay, so we are going to start by graphing this. Now when we make that hill and we make the valley for steps 1, 2, 3, and 4, how high do we go from the midline? How low do we go? Please put an arrow in front of the sign. Whatever value is in front of the sign is going to tell us how much we're going to go above or below that midline. And again, if you don't see a value, it's a hidden 1. So we're going to count. Like many of you, I am procedural, so we're going to start here. You ready? That's our 0. We haven't started counting yet. Step 1 is a hill. So I'm going to go up 1. Why am I going up 1? Because the value in front is a hidden 1. So I'm going up 1. Step 2 is back to the midline. And maybe you want to make, remember, it's not a V. It's going to be more of a U. Step 3 is a valley, and step 4 is back to the midline. That is one cycle. If you were able to take out something and measure, well, how long is it from the beginning to the end of the cycle? It is a distance of pi over 2. Sorry, it's a difference of 2 pi, excuse me. But each one of these steps, from step 1 to step 2 to step 3 to step 4 on the horizontal axis, is a distance of 1 pi over 2. Okay, you're going to grab this right now, and I'm going to teach you a shortcut to this. Please write down, these are the steps. Write down 1, leave space, 2, leave space, 3, and 4, and put a parenthesis behind each. All right, inside of this, so this is, we're on step 3. Step 1 was figure out the period length. Step 2 was the x scale. Step 3, I guess I graphed it. I guess I'm on step 4 here. So step 4, what I'm going to do next is I'm going to take whatever the x scale is. It's always this. Whatever the x scale is, and I'm going to drop it into each one of these parentheses. So this is 1 pi over 2 in each of the parentheses. Okay, but I need Davey focused right now. He's not. You got done with the new PowerPoint that I just put up today? That's today's class. Okay, you ready? So for step 1, you're like, I don't know what I'm doing here, Miss Bradley. What we're going to do now is if I pointed to this point, let me see if I can use a little highlighter so it stands out. If I pointed to this point right here on the x-axis, and I said to us, what is that x? What is that x? What is the distance from the origin to this point? All you're going to do is, this is step 1. Step 1 is above that. So I take 1 times this quantity. Well, 1 times 1 is 1, and 1 over 2 doesn't reduce. At this point on the x-axis, this little tick mark is at 1 pi over 2. This is like a tick mark of 2. It's a second tick mark on the x-axis. Well, what really is that measurement? 2 times 1 is 2, but 2 over 2 reduces just 2 pi. So at the second tick mark, we're at pi. I'm going to go to the third tick mark. 1 times 3 is 3. 3 pi over 2 can't reduce, so this third tick mark is 3 pi over 2. And the last one. 4 times 1 is 4, and 4 over 2 reduces to 2 pi. So this last one is going to be at 2 pi. What have we done so far? We figured out what is the length of one cycle. We figured out what is the distance from one step to the next, and we can identify each one of these tick marks where it is found along the horizontal axis. The last part is by far the easiest. We're going to take this, and this will take us less than 20 seconds to do. We're going to take this, and like a wave curve, it just keeps going. If you can follow a pattern, it just keeps going. So right here, which way do you think I'm going to go up? Up right here is next, then back down, and back down over. And we're just going to continue to draw that curve. And then continue to take the curve in the opposite direction. So down here, I'm not going to go up next. If I follow this curve, which way am I going to go now? If I'm going to go to the left of the origin, I'm going to go down. Make sure that once you've done this, it looks like a continuous curve. What I have in black represents one cycle. So how many cycles are to the right of the origin? 2 cycles, watch. Hill Valley, that's 1 cycle. Hill Valley, that's 2 cycles. So we'll put a 2. And what is each cycle? What is the length of each cycle? 2 pi. So I just went 4 pi to the right. Because I'm going to the right, it's positive. Think of a number line. As you go to the right of the origin, it's positive. As you go to the left, it's negative. Okay, let's do this one. Now, even though this cycle went down first, I still have a hill and a valley. So this is 1 cycle to the left of the origin. Whenever we go to the left of the origin, it's negative. And I did 1 cycle. A cycle is 2 pi. Okay, let's go up to the next one. I would like you to write in the next equation. Let me zoom in here so you can see this. Okay, I would like you to write in, this is going to be negative 3 sine of 2x. Negative 3 sine of 2x. Okay, is everybody ready? So what's the very first thing? Turn to one person next to you. Look back at your notes. What's the first thing we should do? Go. First thing we should do, because I know this is super confusing. Estras, can you tell me what's the first thing we should try to find? Period. Awesome. Period is the first thing. So I'm going to do it on a separate piece of paper. You have more than enough room to do it here. Okay, more than enough room. I always take 2 pi and I divide it by whatever number is in front of the x. So draw a little arrow in front of the x. Always 2 pi divided by whatever number is in front of the x. This time there's a number that I can see. It's not a hidden 1. When I reduce this, what am I left with? So up here, I'm going to write pi. So 1 cycle, 1 hill and valley is going to be a distance of pi. Now in this next part, which is the x scale, that's step number 2, x scale step number 2, I'm always going to take whatever the period is, and I'm always going to divide it by 4. What is the reason for that? There's 4 steps. So I'm going to take that period length, I'm going to divide it into 4 equal parts. Karen, you paying attention? Okay. So the third thing we're going to do is we're going to graph 1 cycle. Now this is where it's tricky. Don't do anything yet. Do you think I'm going to go up 3 or down 3 first? And what is your reason? Turn to your partner, not to me. Go. Do you think I'm going to go up? So normally we go hill, valley. We normally go hill, then valley. Do you think based on this, I'm going to go up first or down first? Talk to your partner. Go. We generally would always go up 3. That's what we always would do. But what makes me say I have to go down first? The negative sign. So here we go. We're just going to reverse it. This time we go down first. So go down 3 and then make sure that it's curved. It's not like a sharp V. And then we go up 3. So I've done steps 1, 2, 3, and there's 4. That's 1 cycle of this sine function, and I know that 1 cycle is a distance of pi. Let me call on somebody randomly to see if they can answer this. Are you ready? Let's go with Yvette. Yvette, the distance from here to step 1 on the horizontal axis, step 2, each of these has a distance of what? It's the x scale. What is this distance? No? Look at the x scale that we determined. 1 pi over 4. 1 pi over 4. So I'm taking whatever this is and dividing it by 4. So this is 1 pi over 4. This distance is 1 pi over 4. They're all equal distances. Everybody grab your paper now, and I want you to write down 1 leave a parenthesis, 2, 3, and 4. Inside those parentheses, you will always write down, every single time, you're going to write down what the X scale is. So here we go. In this position here, when I simplify, I have 1 times pi divided by 4. Well, there's nothing more I can do. 1 pi over 4. Now, that's step 1. So just so everybody knows, at this position right here, this little ticker, I'll use a highlighter. This is 1 pi over 4 on the x-axis. Now, this next one, this would give me 2 pi over 4, but 2 pi over 4 reduces to what? 1 pi over 2, or 1/2 pi. So at this position, you're at 1/2 pi, or 1 pi over 2. Now 3 pi over 4, it can't reduce. At this position, you'd be at 3 pi over 4, and 4 pi over 4 reduces to simply pi, or 1 pi. I would like you, without my assistance, to continue this wave curve to the right and to the left. Go ahead, please, in the same pattern. By a thumbs up or a thumbs down, answer this question. How many felt comfortable continuing the wave to the right and the left? How many feel like I could follow that pattern? Okay, so how many cycles from, if I cover up this part, how many cycles do you guys see here? 2 cycles. One is in black, the other is in pink, so I'm going to write 2 down. You're going to notice we're always doing 2 cycles to the right. Every single time is what we're doing right now in class. Okay, and 1 cycle is a distance of 2 pi. So when I take 2 times that, I end up with, I just went 2 pi to the right. Now I did 1 cycle, I did a hill and a valley to the left, so 1 cycle to the left. Well, 1 cycle is a distance of pi, and because I went to the left, it's a negative pi. I'm going to leave a little space here. We'll probably come back to these, but just a little bit of space. Let's come to the next one, and I want you to type in, or write in here, 4 sine of pi x. 4 sine of pi x. I want you to only figure out the period, and let's see if you can be done, and check with your partner in 30 seconds. Go. You get around with your page, you're learning. I made this purposely a little bit tricky. What is the period length? So to figure out the period length, we always take 2 pi and we divide it by whatever is in front of the x. Now we're used to seeing a number, or maybe even a hidden number like 1. This time, what do we see in front of the x? A pi. Now, how can I simplify 2 pi over pi? How does it simplify? What happens to the pi's? They cancel out, and I'm left with simply 2. So just 2. Raise your hand if you're able to get that right. Okay, about 5 or 6 of us. Nice job. So the period is 2. Now, how many steps are there always to a sine curve? How many steps? 4. We always take whatever the period is, and we always divide it by 4. So 2 over 4 is going to be your x scale, but I know I can reduce 2 over 4. What does 2 over 4 reduce to? It reduces to 1/2. Okay, are you ready? It's time for us to draw this. We always start here right now. We'll learn later when we're going to adjust that graph, but for now we always start at the origin. Do I go up or down first, and how far do I go up or down? Don't do it, just talk to your partner. 10 seconds, go. Draw an arrow to this 4. If that number out front is negative, I go down first in step 1. If it's positive, I go up. Since it's positive, how much will I go up for step number 1? I will go up 4. 1, 2, 3, 4. That's step 1. Step 2 is back to the midline. Step 3 is down, so I'm doing that hill and then valley. And make sure that it is rounded. Okay, you ready? We're taking this like a practice quiz right now. Turn to your partner. Tell your partner, if you had to measure the length of this cycle, horizontal length, what is the horizontal length? Go, turn to your partner. What is it? What is it from here to here? That is the period length. What's the period length? 2. It's a period length is 2. Now, what's this distance? 1/2. What's this distance? 1/2. What's this distance? 1/2. Okay. Next, I want you to write 1 through 4 down on a piece of paper, putting parentheses behind each one. Inside the parentheses, I want you to write down the x scale. Well, the x scale for this problem is 1/2. With your partner, I want you to reduce each one of those. And I will say, okay, at step 1, where are you on the x-axis? Step 2, where are you on the x-axis? I'm going to give you 30 seconds. Please complete that. Dave, can you focus? No. What? Okay, can you take out your computer? Can you put your phone down to the side? Take your phone. I want you to learn. Flip it upside down. Flip it upside down. Perfect. Here we go. You're welcome, David, to take your PowerPoint up. It's on the 0-hour page. That's what they're doing. We're not looking at PowerPoint. This reduces to 1/2. This reduces to 1. This reduces to 3/2, and this reduces to 2. You will notice that step 4 will always be the same as the period length. So if I said to somebody, Giselle, step 1 on the x-axis, where are you at? 1/2. Nice job. Melisa, step 2 on the x-axis, where are you? 1. Maria, step 4, where are you? Step 4. Can anybody tell her, where are we? 2. I just purposely skipped step 3 there to see if she was paying attention. And step 3 would be at 3/2. Okay, I want you to continue the cycle to the right and the left. You have 15 seconds, go. How many cycles did I tell you are always going to be to the right in your homework right now or your quizzes? How many cycles are to the right? We see a blue one and we see a pink. So there's 2 cycles to the right. Every cycle is a distance of 2. So I just went a distance of 4 to the right. And now to the left of the origin there is 1 cycle. But I'm not going to write down 2 even though I know that the distance is 2. Because I go to the left, it's going to be a -2. Here's my first question. What's the very first step you should do? Let's get prepared like this is an actual quiz. So whether you did this or not, what is the first thing you should do? We should figure out the period length. So I'm going to come up here and I'm going to write 2 pi and I'm going to divide it by whatever's in front of the x. What's in front of the x? A 1. Well, 2 pi divided by 1 is still 2 pi. So if you don't have that, please write 2 pi that position. So that would be like a point on a quiz, even if you graph it wrong. How many of you have 2 pi in that position? Hands up high. Okay, x scale. Take 2 pi and ask yourself, how many steps are there when you're going to graph a sign? So even if you don't reduce, if you have 2 pi over 4, I'd be accepting of that. Now, I know that reduces to 1 pi over 2 or pi over 2, but I'd be totally accepting of 2 pi over 4 or 1 pi over 2. Okay, now it's time to start graphing it. This is not step 1. This is where we're going to start from. My question to you is, am I going to go up or down in my first step? Why am I going down? And how far am I going down? Half. So go to step 1 and go down a half. Then go back up to the midline. Go up and back again. Help your partner to achieve this. That is one cycle. That's tough stuff. That was very confusing for students in other classes. So this is one cycle. This one cycle is a distance of 2 pi. And from one step horizontally to the next step, it's a distance of 1 pi over 2. Please write down one. Please write 1, 2, 3, and 4 with the parenthesis behind each. Okay, what goes into these positions? Because that was confusing for other students. What goes into the parentheses? Anybody? It's always the x scale. So 1 pi over 2. 1 pi over 2. 1 pi over 2. 1 pi over 2. And then I'm going to multiply. Let me zoom out here so you guys can see this. Then I'm going to multiply. Let me come back over. I'm sorry. So at step 1 on the x-axis, 1 times 1 is 1. I have 1 pi over 2. It can't be reduced. On the x-axis, when I'm looking here at this right here, at that little ticker mark, that is at 1 pi over 2. Now at the second ticker mark right here on the x-axis, 2 times 1 is 2. 2 divided by 2 is 1. 1 pi. So the second ticker mark right here is going to be at 1 pi. The next one is going to be 3 pi over 2. That doesn't reduce. So this is going to be at 3 pi over 2 for an x value. And the last one is 4 pi over 2. Well, 4 pi over 2 reduces to 2 pi. So this is going to be at 2 pi. Please do me a favor. Continue the cycle to the left and to the right. Go, go, go. To the left and to the right. All right, here we go. So even if you can do the first cycle and you can copy that pattern, that's points for you. Make sure that it is neat so I can see exactly where you're trying to hit these steps. How many cycles did I go to the right of the origin? That happens every time. How many steps? We went 2 to the right. 2 cycles to the right. Each cycle is 2 pi. Maria, pay attention. When I take 2 times 2 pi, I just went 4 pi to the right. Now I just did 1 cycle to the left. Is it going to be like that for you? Yes, 1 cycle for all these to the left. What is 1 cycle? But why would it be wrong if I just put down 2 pi? I have to do something else with it. What do I have to do? A negative because I went to the left.